Hey everyone, Ashish on this side from Innovate Yourself. Welcome back to another exciting video in the series of ESP In today's video, we are diving into the world of EEPROMs, especially the AT24C256N module. This is a highly versatile and reliable module for storing data in your microcontroller projects. Whether you are building a data logger, a configurational storage, or a simple IoT project, this EEPROM has got you covered. So let's get started.
Here it is, the AT24C256N EEPROM module. Let's start with a quick overview of its technical specification. It's a 256 kilobit EEPROM which translates to 32 kilobytes of storage. It operates over an I2C interface, making it compatible with most microcontrollers like Arduino, ESP32 and Raspberry Pi. It has a wide voltage range working between 2.7 volt to 5.5 volt, making it suitable for both 3.3 volt and 5 volt logic levels. The module has an endurance of 1 million write or erase cycles and a data retention period of over 100 years, ensuring durability and reliability for long-term use. Now let's talk about the physical layout of the module. You can see here we have 4 pins, which is the main pin, you can say, VCC and ground, which are for powering the module, SCL and SDA, which is serial clock and serial data, which are the I2C communication. Most I2C devices share the same clock and data lines, so you can connect multiple devices on the same bus as long as their addresses don't conflict.
Alright everyone, so here you can see these are the connections between the EEPROM, which is 24C256N. So this is the EEPROM, or you can say this is the external EEPROM which we are connecting to the ESP32 dev board which we are using right now. So basically here we have made four connections using the jumpers. One is connected to VCC. VCC is connected to the V-in pin of ESP32. So let me mention it here. VCC is connected to V-in, right? So this is how we are doing it. Similarly, your GND is connected to GND, right? So this is how we have made the connections. And similarly, your SCL, which is serial clock, and second is SDA, which is serial data, that is connected to the pin of 21 and 22. So basically here it is this purple color wire which is right here, that is SCL, that is connected to like here, and that is pin number 22, right? So this is pin number 22, and the other one is SDA, which is this blue color jumper, that is connected to pin number 21. So this is the way how we have to make the connections of your EEPROM with the ESP32. Now that we have made the connections, we'll move further to the coding part and we'll understand how we will flash the code, or you can say how we will flash the data to the EEPROM, and accordingly how we will read it back using the ESP IDF with ESP32. So let's proceed and let's understand how are we going to do that.
Alright everyone, now that we have made the connections of your EEPROM with ESP32, now we can move ahead to the coding part. And in today's video, I'll take the basic example of the I2C communication with the EEPROM to read and write the data to its storage, which is EEPROM. So for that, let me go to the folder, or you can say to the project in which we have the code for the EEPROM with the I2C protocol, which we will be using in today's video. So let me go there and let me explain you a bit more about that. So now basically right now you can see I have two directories with the name ESP IDF. One is ESP underscore IDF, one is ESP hyphen IDF, and we have these two directories for a reason. I'll tell you the reason, but firstly let me go inside this, which is marked as red, which I have marked red specially. So let me go in here to the peripherals, to I2C. And right now you can see over here we have three projects. One is I2C self test, one is I2C simple, one is I2C tools. But out of these three, there is no project which is for reading and writing the data for EEPROM. And in case you are also able to see something like this, then most probably you haven't upgraded your ESP IDF Git repository with your current version. So that is the reason why you are able to see this. And now let me tell you where exactly we will be able to get the example for EEPROM. So for that, I'll go to this other directory, and basically this is the latest pull from the repository, in which we have the entire examples and entire things about the ESP IDF configurations and everything, right? Now I'll go inside this to the examples, peripherals, I2C, and here you can see this is the example which we have to understand today to read and write the operations to the external EEPROM which we have with us. Now open it up. So yes, I trust the author. Okay, now this is that project in which we will be able to understand the code, like how we can read and write the operations to the EEPROM which we have interfaced with the ESP32. Now to understand this, I'll go inside this, and this is the main I2C EEPROM underscore main.c, right? Now over here, this is the entire project, and inside this entire project, let me tell you what exactly we are doing. Firstly, this is app underscore main, which is the main function of this complete project as per the ESP IDF configuration, right? And over here, firstly we are setting up the configuration, how exactly we are going to use the I2C protocol, and for using the I2C protocol, to which pins we have connected our EEPROM with ESP32. So basically this SCL pin and SDA pins, these are the one which is like mentioned right here. And this configuration is basically inside the menu configuration, where we will specify the pin numbers as 21 and 22 respectively for SCL and SDA, which I have already explained you in the previous previous part of this video, where I showed you what where is SCL connected and where is SDA connected. So accordingly we'll simply set up 21 and 22 for that. So based on that, we are setting up this configuration, and currently we are using this I2C as a master, not as a slave. So that is the reason we are setting up the master configuration for this. And accordingly, we are also setting up the port for this. And what is the port number right here? Port number we have set up as -1 for this. So that's what it will be. And accordingly, initially we are just initializing these things up. We are just setting up the configuration, we are putting up the bus handle. So this is the bus handle which we have created, and according to the EEPROM and according to the device address, 0x50 is a device address for EEPROM. That's why we have it right here. And frequency, we also have it here. This frequency will be set up again in the menu configuration part. I'll go to that point as well. And now let's come to the main part of this entire project. So basically right now we are doing two things. One is writing the operation, second is reading the operation on the EEPROM basically, right? So firstly, right now what exactly we are doing is we are just writing up the data, and the data which we are writing up is you can say a sequence basically, right? So you can see here we have written like length. This is the length, and the length will be like 48, which is specified right here. And accordingly we are taking up a buffer in which we are just simply storing the values, and the values are getting stored from 0 to the length, right? So whatever is the length, that is 48, so we are taking up the values from 0 to 47. So these values are getting up stored in the buffer variable which we have initialized right here, and the same thing and the same data will be stored, or you can say this will be written into this EEPROM. So you can see this is the command to write the data to the EEPROM. This is how exactly we're writing it up. Similarly, once we have written it up, what we are doing is we are just again using this command to read the data from the EEPROM, so that we can validate what data we have written, and whatever data we have written, are we getting it back or not, right? So this is what we are doing. And I'll show you the modification for this as well, so that I can show you it's not just about the number, but we can also put the characters as well, right? So this is the entire code for reading and writing up of the EEPROM, right? So first we initialize it, then we do the writing and reading operations, right? So this is what we are doing right here. Now let me do one thing. Let me connect my ESP32 to the system, so that I can flash the code and I can start working accordingly, right? So let me do that. Allow it. And while installing, or you can say while uploading the code to the ESP32, just make sure you are using the latest version with the latest Git repository, because then only we'll be able to flash the program. Otherwise it will create a problem in between, right? So just make sure you're using the latest version for the Git repository as well as for the ESP IDF, right? So let's move ahead and let's flash the program. Firstly, we'll go to the menu configuration. All right, everyone. So now you can see I have opened the menu configuration. Now over here, you can see one option with the name example configuration. Just go inside, and here you need to set the SCL and SDA pin, which I already mentioned like previously to you, right? So as per the SCL, so SCL is gonna be pin number 22. Just set is 22, and this one will be pin number 21, right? And the master frequency is like 4 lakh. So just let it be, you don't have to change it. And go back, the other configuration are the basic one, which I have already shown you in my previous videos. So as per that, you can set the flash, and you can set the flash SPI speed, and accordingly you can go in here and you can set up the frequency as well, CPU frequency basically, which is 240 megahertz. So this is all that we need to set up, and I'm already done with that. Now what next I can do is I just have to simply connect my device to the system, so that I can flash the program. So firstly I'll simply write idf.p by build. I'll have to build it, and I'm gonna write both the commands in just same line. So I'll simply write it like flash and monitor. I'm not setting up the port because I'm assuming it will automatically pick it up. Now you can see it started flashing the code. Now one more thing we have to check here is that all our connections from ESP32 to EEPROMs are connected successfully and without any fault in that. In case we are getting any issue, or let's say in case any of the connection, let's say the ground is not connected properly, or let's say the VCC is not connected properly, or SCL or SDA pin are not connected properly, in that case what is going to happen is it's continuously gonna start throwing up the errors. and that is obviously simply means that your connections are not strong. And the reason being, in the code, if we will go back, we will see that there is one code that says needs wait for EEPROM hardware done, referring from datasheet. So basically what is happening is, in case the connections are not done properly, then it won't allow you to proceed further, and it won't allow you to read the data back from the EEPROM. So that is the reason it will simply gonna throw up the error, and I can show you that either. So right now what I'm about to do is I'm simply gonna remove the ground pin, and let's see what happens. Can you see? I removed the ground pin and it started throwing up the error. Now let me connect it back. See, now the connections are made properly. That means everything is working absolutely fine. So this is what is going to happen if the connections are not strong and if the connections are not correct, right? So this is how it's going to happen. Now let me stop this. Okay. So, one more thing that I wanted to show you is, instead of showing it like this, instead of putting up the values in the buffer by using this for loop, I'll simply comment this up, and instead this time I'll simply put a text, right? So let's say my name is from Innovate Yourself, and this is EEPROM project video, right? And one more thing you have to take care is, just because right now the length is 48 as per this, so as per that we have to have the character length as 48 only. It should not be exceeding that. So just make sure that the length is that only, otherwise it may cause some issue, right? So let me check whether the length is correct or wrong, right? So okay, so the length is exceeding basically. So I'll remove this one. And in case you have to change the length and everything, and let's say if you don't want the length to be 48, you want to change it or you want to increase it, in that case you have to change the length as well as you have to change the block address as well. Then only you will be able to get this length thing properly, right? So right now I'm gonna show you with this, because this is length 48, right? So let me flash it again. All right. So now you can see we are getting some code. So this is basically that code which we are getting right now. So this is basically in the hex code. Now let me show you by converting it to the text, so that we can understand like what exactly this means, right? So basically the text which we are getting right now, after conversion we should be getting the same what we have passed in here, because we are just writing it and we are just reading it back. So it should be exactly the same. So let me just check it, like what does this hex code means, right? So let me open up in a browser. So simply search for it, hex to string. Okay, I'll pass this here, and this is text. Now let's convert it. Okay, so you can see right here, this is what I just passed, and this is what I'm getting after converting it to the string part, after converting it to the text part, right? And encoding here, we can see we have just selected it as ASCII, because these are basically kind of ASCII characters, right? Which are converted to hexadecimal, right? So this is what exactly we are getting, and this is what we were writing to the EEPROM. So whatever we have wrote, same thing we are getting back like here, right? So this is all about connecting and interfacing your ESP32 with the EEPROM, which is 24C256N, the one which we are using today. I hope this was a very really helpful video for you. In case you are facing any difficulties in understanding anything, or in case you are having any doubts, feel free to leave a comment below in the comment section so that I can help you as soon as possible. So this was it for today. I hope you have liked the video. Do click on the like button if you have liked the video, and if you're new to this channel and if you haven't subscribed to our channel yet, do click on the subscribe button so that you will not miss any videos from our channel. Thank you so much and stay tuned to our channel.